inequalities. If you look at the front side, we're solving. And a lot of you already know how to do this. I know you work ahead of me and you're going to be doing awesome on those on your own because they do look familiar. We are then at the very end of our notes after the on your own going to take a look at how you can write your own compound inequalities from a graph. All right? These and inequalities, that was the part I was talking about while I walked around the room. They need to include only the values that will make both inequalities true. All right? And so often, for these and inequalities, they're found in the exact same places we were finding our solutions. We were picking numbers between 3 and 5. So we're still going to solve for boundary points, but our solutions are going to have to be between those. The other type of compound inequality we can have is an OR inequality. Okay? And when we make an OR statement, if I tell Bailey, I'm going to give her an A or a B, I have two options of grades I can give her, correct? And not be lying to her. Okay? I don't have to give her both of them. If I tell Jake, though, that I'm going to give him $5 and a Big Mac, I have to give him both those things, correct? So the difference between an and an or is an or only has to have one true statement, one true thing to actually work and be a true, still be a true statement, to not be a lie. All right, so we'll take a look at what those look like. They have some very major characteristics that are different to help us separate them. All right, to solve any compound inequality, we're always going to isolate the variable. But the difference between an and compound inequality is because we're looking for solutions between our two boundaries, our x is going to be between those two inequalities. So it looks like one long statement, ladies and gentlemen, but you actually have two inequalities that you're solving. But we're going to solve them at the same time. So it's kind of nice. You kind of get two for the price of one. You get two answers by doing the work of one. So we're going to look at where x is at, and we're going to solve that the way we were on Monday. So am I going to undo my multiplication or undo my subtraction first? Undo your subtraction first. But remember, guys, I've got to solve two inequalities at the same time. So I can't just add 3 to the 7. Guess where else I have to add 3 at? I have to add it to the -9. They're sharing that statement. And because they share that statement, they're going to share all of my algebra steps. So it looks a little weird because instead of just adding 3 to one side, I'm actually adding that 3 to every single part. Here it cancels out. And then I'm going to have -6 is less than 2x is less than 10. Keep in mind, guys, that example I gave you. I asked you for numbers that were greater than 3 and less than 5. We had two boundary points, correct? I gave you two ranges, 3 and 5. For these and inequalities, you're going to need the same thing. You're going to have to give me two boundary points. So if you ever get down to just two numbers in the problem, you know you've ran into some sort of problem. We have 1, 2, 3 numbers at this point, okay? Or I should say two terms in the problem, not two numbers. Once again, we undo multiplication with division. Our algebras haven't changed, but I have to divide by that 2 in all three parts. That shared x has to share all of its algebra with both those inequalities. So I divide by 2. I'm going to have -3 is less than x is less than 5. Looks like a kind of weird way to say it, but what this means is I'm looking for x to be less than 5, and if we look at what this means, x, because it's open by the x, means x is greater than -3. So it has to be greater than -3, but x at the same time has to be less than 5. These are still going to be my boundary points like they were before. So I'm going to graph those boundaries. So I put those on there, and then I usually put 0 still, guys, wherever it would fall. So where does 0 fall in this case? In the middle. So I'm going to put 0, whether it's in the middle or in between the two numbers. So we'll put 0 in there. All right. When I was asking you guys for examples of numbers that were greater than 3 but less than 5, and less than 5, you couldn't go past the 5, correct? And we couldn't go past the 3. We couldn't go below 3. We couldn't go greater than 5. That's the same thing with these and inequalities. I can't go past the -3. I can't go less than that. I can't go below that. And I can't go above the 5. And so what happens is I'm bounded in, I'm stuck between these two numbers, and so that's where all my solutions are going to be. And all the solutions that you guys gave me were between 3 and 5. The 4, the 3.1, the 4.9. Now we're still going to use our open and closed circles the way we did on Monday. Is -3 greater than -3? No, so I can't shade that in. Is 5 less than 5? No, so I can't shade in the 5. So if it's just a less than, just a greater than, we're still going to have to keep those open circles. If we have that or equals to, if we can be equal to our boundary points, then we're going to shade those in. All right? Any questions, ladies and gentlemen? All right, let's go take a look at example 2. All right, ORs are really, really easy. It's exactly what we did on Monday, except you have to do it 2 times for every problem. Each problem is separate, and they're actually separated by the word OR. So our OR inequalities are very easy to identify because they have the word OR in them. And everything's just combined together. All right? So I'm going to take this first one on the left-hand side, solve it the way I do every other inequality. Undo adding by subtracting. Undo my multiplying by dividing. And I get x is less than -5. So that's going to be part of my solution, is every number that's less than -5 can count as part of my solution. And so you can graph that right away. I usually wait until I see my other number.
So
Here, yes.
when graphing, so we put our thing in the middle, so then we will go over to the negative.
Well, I'm not quite ready to graph yet because I haven't found my second solution, correct?
Oh, yeah.
I wait and get my 2 solutions. I'm going to divide by -3. Do we agree that that's how we get rid of that -3 with the x? All right. But because I divided by a negative, what do we have to keep in mind about our inequality? We have to reverse it, so it's no longer all numbers less than. It's going to be all numbers greater than or equal to. Don't lose that equal to. All right. And remember, this is because we divided by a negative on both sides. All right, guys? That was what we talked about on Monday. We didn't see that much with our word problems. Okay, we didn't have much dividing by a negative, but because we divided by that negative on both sides, -21 divided by -3 is 7. So what you're going to tell me is that your solutions
So it'll be -7.
not -7.
I mean +7.
+7. So what you're going to show me is all numbers less than -5. That's one solution for me. Or all numbers greater than 7. Evan, what's your question?
When you divide by -3, shouldn't it be x is less than?
Because it started out less than, correct?
Oh, yeah, that's right.
And because we divided by the negative, that's where it became greater
Oh, I
than.
have that. It's just-
Okay, yeah. So ladies and gentlemen, I do put my -5 and 7 on there just so that I get them in the right positions, okay? Because if this had been a -7, it would have had to go on this side, and then my graph is getting really crowded down there. So I wait till I solve both of them, but then I'm graphing all numbers less than -5. Open circle, because -5 is not a solution. It can't be equal. And then I shade less than. Here I'm going to actually shade 7 because 7 is greater than or equal to 7. So I can fill that in because I can equal 7. And then I shade everything greater than 7. So those are and or inequalities. All right? What I need you guys to do for me now is to go to the back side. I said you need to, if you have it right, do a +1. If it's wrong, you just need to write in the correct answer and do -1 so I can come around and record these. This is an or inequality, so right away I know I'm going to have 2 separate answers. All right? They don't need to overlap. There's nothing that they have to have in common. So I'm simply going to solve. I get 4x is less than 4 when I subtract 7. When I divide by 4, I get x is less than 1. Here I'm going to add 8. And when I divide by 3, I get x is greater than 8. I don't need to reverse any of my inequalities because I didn't multiply or divide by any negatives. So I want all of the x's values. I want all the numbers less than 1. I want all the numbers greater than or equal to 8. 0 is off to the side here, so you could put 0 here. But I want to have an open circle because 1 is not a solution. 1 is not less than 1. So I can't shade in the 1. And I go less than. Here, I want to fill in the circle at 8 because 8 is a true statement. 8 is greater than or equal to 8. And I shade all the numbers greater than 8, 9, 10, 11. So that's what our number 1 should look like. If you have all that correct, put a +1 next to it. If you didn't have that, -1.
Or you didn't grab.
You didn't graph, -1.
I got the problem though.
Well, you gotta follow directions. I don't know how, -1/2 then. How about we do that? I gotta have a way of collecting data, Cameron. And so if I don't have your graph to see if you're graphing the right way, then I can't give you full credit. And it's just for me to, it never goes in the grade book. So it doesn't really matter if you get a half point, you get a whole point. Does that make sense? But you gotta start reading directions carefully. All right, this is our and inequality. Hunter, you asked, how do I know the difference? The and will never have any words. It's all in between. Sasha, you were asking about shading. This kind of helps me out. Where's my X at? It's in between the two problems, so my shading is going to be in between them. Our algebra book sets it up really nicely for you that every single problem we do for our ands are always going to be in between. A couple of the algebra books I taught at other districts didn't always have them work out this way. This one will. So I'm going to add 15 to each side. And so I get 3 is less than or equal to 3x. So 3 has to be less than the 3x. And this has to be less than or equal to
24 over
24, correct?
three.
We need to still divide by 3. Thank you, Cameron. So do we get a 1 here? We're going to have 1 has to be less than x. So 1's my smallest number. Has to be less than everything. And this is going to be, x has to be less than or equal to 8. So 8 is going to be my largest number. We put those two numbers on the number line. These are both going to be closed circles because I can be equal to 1 and I can be equal to 8. And then all of my solutions are found the same place my x's in between those. All right? If you had everything correct, +1. If you had the solutions but not the graph, +0.5. If you had done it right, -1. I guess it's not a big deal. I just have to have something. Like, I hate turning in data. This is what I have to do.
I got these, but I just didn't.
Same thing? Yep. All right. So 1 out of 2. All right. Ladies and gentlemen, now you're going to write compound inequalities for me. How does this sound? Terrible. Great. That's what I was hoping for. All right. Can we at least tell which one's an and which one's an or? Yeah. This is how Miss Nichols, you guys didn't get the chance to have her. She used to teach 8th grade math. She reminds her students that the or inequalities actually look like the oars on the boat. Where do you find the oars on the boat? On the outside, 1 on each side, correct? You put both your oars on one side and you have a pretty dysfunctional boat. So for our or inequality, yeah, you're not ready to spill in the water. So for our or inequalities, we're going to see 2 separate graphs, all right? So this one is going to be our or. I put the word or right here, right where the opening is at. And then I write exactly what I see. I see all numbers. What direction is this headed? To the right. So I see all numbers greater than. And what's my boundary here? 3. Am I equal to 3? How can you tell? Because it's an open circle. All right, I go here. X, all numbers. What direction is it going? To the left. So these are all less than. And what's my boundary? 0. Am I equal to 0? Because of the closed circle. Boom. Done. Easy peasy lemon squeezy. We got it?
Yes, ma'am.
All right, let's take a look at the second one. And, correct? But we're not going to use the word and, ladies and gentlemen. I'm going to put X in the middle where my shading is at. Sebastian. No, it doesn't matter which side they're on. You just have to have an X greater than 3 and an X less than or equal to 0. I just usually put them in the order that I find them on my graph because that's, my brain just works that way. All right, ladies and gentlemen, 5 and -5 are my 2 boundaries, correct? Or wait, is it 5 and -5? 6 and -4? Thank you. All right, are these numbers less than 6 or greater than 6? 0 is less than 6. Is 0 greater than -4 or less than -4? So So I need to have it open towards the x. The cool thing about and inequalities, ladies and gentlemen, is they're both going to look like less thans. That's all you ever use for your ands, is the two less thans. Now, am I done? Is this a complete problem? No, what's missing? My equal to, I got to have an equal to there. Ladies and gentlemen, how many people feel pretty confident with those? Awesome. So your assignment is in that lovely thing you call a textbook. Mr. Key, make sure you're getting those correct.